Section 5.2 Binomial Probability Distribution. These sessions, we're still working on the probability distribution, meaning we have to meet the three requirements: the numerical outcome, each probability between 0 and 1, and sum of all probabilities must be equal to 1. And you could see that's called binomial. That's a specific type of binomial probability distribution. Let's look at this example. So your favorite fast food chain is giving away a coupon. So you're gonna get a coupon when you purchase a meal. When you scratch the coupon, you will have a 20% chance to get the free burger. And the rest of them say better not next time. So first here, think about it. If the coupon you only have get the free burger or better not next time. If this is the 20%, how many percent would gonna get the better not next time? It should be 80%, right? When you add it up, it's gonna be 100%. And we call this is gonna be the complement, okay? When they add it up, has to be equal to 1. Now, you go to this restaurant in a group of 10 people. And everyone orders lunch. So everyone orders lunch, everyone gonna get the coupon. I want to find out what is probability that 3 of you win a free burger. Okay, I want to know 10 people, 10 coupons, and I want to know the probability 3 of you win a free burger. So this kind of the example we call this is the binomial distribution. And since we want to find the probability that 3 of you win a free burger, so we're gonna let X be the number of the people out of 10 who win a free burger. Okay, so the X here, it depends on what you are looking for. For example, if I say, what is the probability that 2 of you get better the next time? If my question changed to get better the next time, then I will let the X be the number of the people who get better the next time. And look at the binomial distribution. We do have the requirement. First requirement, the procedure has a fixed number of trials. Just like this example, we have 10 people to go to this restaurant to order the lunch. So we got the 10 coupons. This is called fixed number of trials. And we have 10 trials in here. Second, the trials must be independent. So the outcome of any individual trial doesn't affect the probabilities in the other's trial. So for example, if you are the first one who got the coupon, you do have a 20% chance to get the free burger. And no matter you get the free burger or not, it doesn't affect for the next one. Have the same percentage to get the free burger. Okay, so this is called the independent. Number 3, each trial must have all outcomes classified into 2 categories. Okay, we have 2 categories. We call success and failure. Okay, we only have 2 categories, success and failure. So in this example, since we are looking for the probability to get the free burger, so we consider getting the free burger will be the success, and better not next time will be the failure. Okay. Last one, probability of success will remain the same in all trials. So they will have the same percentage to win the free burger on each coupon. So probability of success will remain the same in all trials. Make sure you guys remember these 4 requirements. If the example fulfill these 4 requirements, we consider this is binomial probability distribution. Okay, using the binomial probability formula. So you could see the P of X equal to, this is the combination. We talk about this guy on the session 4.4. Okay, that's an NCR at that time. So here NCX. The X represent the probability in here. Okay. So NCX, if you could use the calculator or you could plug into this formula. Okay, let's look at the notation. First, N. N represent the number of trials. So for our example, we have a 10 coupon. So N equal to 10. X represent the number of success among N trials. So we are looking for the probability that 3 of them win a free burger. So my X is gonna be equal to 3. And keep in mind, your X is always in between 0 and N. Think about it, like if you only have a 10 coupons, you won't be able to get like 11 free burger, right? So X is always in between 0 and N. Okay, P. P represents probability of success in any one trial. So we do have a 20% chance to win a free burger. So we consider P equal to 0.2. Okay, 20% means like 0.2. Q represents probability of failure in any one trial. So P and Q, that is a complement. If P is 0.2, Q, that will be 0.8. P of X, that's talking about the probability of getting exactly 3 success among the N trials. So we are looking for the P of 3 in here. Okay, once you guys know the notation, you could use the formula. But I highly recommend you guys try to use the calculator for these sessions. It will be a lot easier. Okay, this is like how you guys using your calculator. Okay, go to the second VAS or second distribution. You're gonna see the first one. To calculate the X, you're gonna use the binom PDF. Okay, binom PDF. Binom PDF functions means the probability of exactly some number of success. Okay, the P here, I want you guys to highlight the P. The P here, this is means exactly at X. For example, if we are looking for the P of 3, so that would be the binom PDF, N will be the 10, P will be the probability of success, that will be 0.2, and then my value will be equal to the 3, okay, binom PDF. Second one, when we working for the X less than or equal to a value, we'll be using the binom CDF. Okay, binom CDF functions means like cumulative probability for that value and all the values below it. So remember that the C here means cumulative, okay, cumulative starting from 0 to X. Okay, this is means you're looking for, let's say, X less than or equal to 3. So you may want to find the P of 0, P of 1, P of 2, and then P of 3. After you guys finding the probability, you need to know how to find out the mean, variance, and the standard deviation. Okay, the formula will be given on the exam. So if you know the N and the P, just multiply it, you're gonna get the mean. NPQ, that will be the variance. Take the square root of the variance, you're gonna get the standard deviation. Okay, you should have an idea what we are talking about, what is a binomial distribution. For the calculation part, let me use the first example to explain like this guy here. Okay, example 1. A biased coin has a probability 0.6 of coming up heads. The coin is tossed 8 times, and let x be the number of heads that comes up. Since x is the number of heads, coming up heads is a success. Okay, we're gonna flip the biased coins, and getting the head is gonna be 0.6, and we're gonna flip the coins like 8 times. So first, what is probability of getting exactly 2 of the toes are heads? So before we're working on these questions, we have to make sure, do we fulfill the 4 requirements for the binomial probability distribution? Remember that 4 requirements? First one, we have a fixed number of trials, right? So we flip the coin like 8 times. This is a fixed number of trials. We fulfill the first requirement. Second requirement, it has to be independent right? Means the first time we flip the coin, it doesn't affect the probability that when you flip the coin again. So that's independent. Number 3, we have two outcomes, either success and failure. Since when you flip the coin, you only can get head or tails. So we have two outcomes, and they're looking for the probability that getting the heads. So heads consider success and tails that's consider failure. And last one, probability remains the same. So every time when we flip the coin, we do have a 0.6 to get the head, and the rest of them we're getting the tails. Okay, so this is gonna be the binomial distribution. Okay, now I want you guys write it down, find out what is your N, what is your P, and what is your Q. So N will be equal to 8, right? We have a fixed child, N equal to 8. And then P, that will be 0.6, okay? The success to getting the head will be 0.6. Q, that will be the complement. So subtract from 1, this guy's going to be 0.4 here. Okay, with the questions one more time. What is probability of getting exactly 2 of those ahead? So we are looking for P of 2, okay? P of 2. P of 2, x equal to 2. When we are getting exactly 2, we'll be using the binomial PDF, okay? PDF, exactly x equal to 2. First one, that'll be the N, which is 8. Second one will be the P, which is going to be 0.6. And then the last one, that'll be X, what you're looking for in here. So equal to 2. Okay, I want you guys write it down first, and then I'm gonna show you guys how to do it with the calculator. Okay, get your calculator ready. So first, do the second vase. Vase is going to be next to the clear. And then scroll down. You're going to see the 0, that's a binomial PDF. And then the 8, that will be binomial CDF. We are working on exactly 2. So we'll be choosing the binomial PDF. Enter. The N, first one is going to be your N, which is going to be 8, comma. And then the P, which is going to be 0.6, comma. And then x equal to 2. So there'll be 2, close parenthesis, enter. So you're going to get 0.0413. Okay, getting 4 decimal space. So round it up 0.0413. Okay, B. What is probability of getting at most 5 heads? Okay, at most. Think about it. What's the meaning of at most? So we're gonna write it as an inequality. At most means less than or equal to. Okay, x less than or equal to 5. Okay, at most. So means like I'm looking for the x which is less than or equal to 5. Which is talking about 5, 4, 0, 1, 2, 3, 4, 5. Okay, 0, 1, 2, 3, 4, 5. So this is at most 5 heads. And now you could see we want to calculate the probability. Okay, now we want to calculate the probability. Cumulative from 0 to 5. Okay, 0 to 5. So we need to use the binomial CDF. Binomial CDF, the first one will be N, comma, P, which is 0.6. And then I'm gonna stop at 5 in here because this is the cumulative probability starting from 0 until 5. Okay, you could try it with your own calculator. Go to the second vase, find out the binomial CDF. You could get this answer. Okay, C. What is probability of getting more than 4 heads? Okay, write it has an inequality. What is a more than 4? That would be x greater than 4, right? So x greater than 4 means we are looking for p of 5, p of 6, p of 7 until p of 8. So we only have a two function, either binom PDF function or binom CDF. For the PDF, we are working on exactly on that number. CDF means we want to find the probability cumulative starting from 0 to 5. But this is not exactly one thing, and this is not starting from 0. So what we can do? Remember the trick that we learned from the session 5.1? If I added up all the probabilities, P of 0, P of 1 until P of 8, it has to be equal to 1, right? And right now, we are looking for the P of 5, P of 6, P of 7, and P of 8. So we could do 1 minus, okay? We are looking from P of 5 to P of 8. So 1 minus the whole thing from here. Okay, they are equal to each other. So for the next step, I'm going to write it like this. 1 minus P of 0 until P of 4. Okay, so this part, this is starting from 0, cumulative from 0 to 4. So that will be 1 minus binom CDF, cumulative starting from 0 until 4. So you could use the calculator. So we could use our calculator. This is going to be 1 minus, and then second bars, choose the binom CDF. First one is going to be 8, comma, 0.6, comma, 4, close parenthesis, enter. So that will be 0.5941, okay? Okay, for the homework and the exam, I need you guys write it down. Make sure you have this part. You need to write it down, P of something, which function you're gonna use, and what number you get, and what is the final answer. Okay, one more time. You could skip the P of 0, P of 1 like this, but this is what I'm looking for. Okay, I need to see these guys. P and then x less than or equal to 5, binom CDF, what numbers here, and what is the final answer. Same idea for last one. I need to see this one for the homework and also the midterm exam. Okay, next one. What is probability of getting at least 3? Okay, at least 3. Think about it. What is the inequality for at least 3? You will have an x greater than 3, right? At least 3 means like you need to 3 or more. So you're looking for P of 3, P of 4, until P of 8. Same idea here. This is not starting from 0. So you need to subtract from 1, okay? So I'm going to do 1 minus P of 0, P of 1, P of 2. Okay, you could look at it as always starting from like this: 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, just like the previous one: 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's always in order. Then now this is cumulative starting from 0. So 1 minus binom CDF and P, and then cumulative starting from 0 to 2. So I'm going to put the 2 here. Make sure you don't look at this number. Okay, you're going to look at it starting from 0 until what value. Then you're going to put it in here. You should get 0.9502. Okay, finding the mean, standard deviation, and variance. Okay, that will be using the formula. You guys know what is the n, right? N equal to 8. P, that will be 0.6 here. So plug it in, you could get 4.8. So variance, n times p times q, 0.6 and 0.4 here, so 1.92. Standard deviation, you could take the square root of this number. It's going to be 1.3856. Okay, Next questions. According to the company, approximately 30% of the United States households had a digital video recorder, okay, the DVR, at the end of the year 2008. Suppose a simple random sample of 15 households is taken. Use the binomial probability distribution to find the following probabilities. Okay, A. Find the probability that exactly 5 of the sample household have a DVR. So here again, make sure you check with the requirement. Do they fulfill the 4 requirement? And then find out the N, find out the P, and find out the Q. So N, that will be equal to 15, right? Because we have 15 household here. And then P, the probability of success, which is going to be 30%, right? So it's going to be 0.3. Q, that will be the complement. So 1 minus 0.3, which is going to be 0.7. Okay, always find out the N and P and Q. Now, exactly 5. So X is going to be equal to 5. We are working on P of 5. And when we're working on exactly that value, we'll be using binom PDF. Okay, binom PDF. First one is going to be N, P, and then the X, which is 5. So you should get 0.206. Okay, B. Find the probability that fewer than 3 of the households have a DVR. So fewer than 3. Widget has an inequality. What is the meaning of fewer than 3? You should have an X strictly less than 3. So means we are looking for P of 0, P of 1, and P of 2. So this is starting from 0. So we're gonna be using binom CDF, cumulative from 0 to 2. Okay, so N, P, and then 2 here. We stop at 2, so we're gonna put the 2 in here. Okay, C. Find the probability that more than one household has a DVR. So more than one. What is more than one? X strictly greater than 1, right? So we are looking for P of 2, P of 3 until P of 15. So this is not starting from 0, so we have to do 1 minus. 1 minus P of 0 and P of 1 here. So again, CDF, and then N, P, and then stop at 1. So cumulative from 0 to 1, so I put the 1 in here. Okay, now plug into the formula. Find out the mean, variance, and the standard deviation. So check your work. Okay.